Chapter 8 is about quadratic equations, quadratic functions, and quadratic inequalities. And this section is about solving quadratic equations. Okay, when we solve a quadratic equation, what do we do first? We first move all the terms on one side so that the other side is 0, and then factor the expression. So, zero factor property. So something like this. Move everything to the left, then it will be a product of something, then that is equal to 0. So once we have this, using the zero factor property, we will set this factor to 0, set this factor to 0. So maybe something like this, a plus 1 times x plus 1 times x plus 2. Then this product is 0, so we can set the first factor equal to 0 and then solve for x, and then set the second factor equal to 0 and then solve for x. And these are the solutions. So let's try factoring this equation. So move 24 to the left, then x squared plus 5x minus 24 is equal to 0. And then let's factor this trinomial. X times x, 24 is 4 times 6 is not working. About 3 times 8. 3 times 8. Let's try 3 times 8. Then 24, and then we gotta put the negative sign, so put it on 3. Then this is negative 3x, 8x. The sum is 5x. So this result is same as the second term. So that the left side of the equation is a product of the first line and the second line. The first one, first expression, and the second expression. It's x minus 3 times x plus 8 equals to 0. And then the first one, set the first equation, binomial 0, then x equals 3 or x equals negative 8. Okay, we have done this one in a previous chapter, so this is no problem. Okay, let's try more. The next one is, okay, move these two terms to the left, then 3x squared. And then when you write the trinomial, make sure you write the largest exponent term first. So make sure to write in the order of, in the descending order of the degrees. Okay, then let's factor this trinomial, x times 3x. 4 is, it can be 1 times 4 or 4 times 1 or 2 times 2. So let's try 1 times 4. And negative sign. Okay, let's try 4 times 1. 4 times 1. And then put the negative sign on 1. So this product is 12x. This product is negative x. Sum is 11x. And same as the second. So this is equal to the first binomial times the second binomial. X plus 4 times 3x minus 1 is equal to 0. So from the first factor, x equals negative 4. Or from the second factor, okay, minus 1, move minus 1 to the other side, then it becomes positive 1. And then divided by 3. The coefficient of x is 3. So we have negative 4 and 1/3. Okay, the next one, okay, move all the terms to the left. So let's move 5x squared to the left. Okay, then this one cancel out. So 4x squared. And then move 12x to the left, so minus 12x. And then minus 3 each side, then plus 9 equals 0. Then this is equal to, okay, try 2x times 2x, and then 3 times 3, and then both negative. So negative 3 times negative 3 is 9, and the cross multiply, then negative 6x, cross multiply, negative 6x, sum is negative 12x. Okay, we got it. So the left side is what? 2x minus 3 times 2x minus 3. Now, these binomial factors are the same. So from each factor, we get x equals 3 over 2 and another 3 over 2. So 3 over 2 is the same, so the solution is 3 over 2. And this one is occurred twice. Okay, so example 1 is okay, fine. Okay, let's try next one. Next one is about the square root property. Okay, square root property is actually a difference of squares. So we will not use different squares, but we'll just use this property. Okay, x squared equals a. X squared is equal to a. We are looking for the value of x, so that x squared will become what? A. So in this case, we can just get rid of this exponent 2. Get rid of the exponent 2, then x is equal to plus or minus square root of the right side. Okay, so this is important. I think we have done this one before. Okay, something squared, you have something squared. So that is equal to, let's say, a moon. Moon, this is a moon. Okay, then the star is equal to, the expression, the base is equal to plus or minus square root of moon. Okay, plus or minus means, okay, the star is equal to, plus means positive square root. Positive square root, or the star, the base is negative square root of the moon. Okay, so it's very simple. Get rid of the square exponent so that we have the base. The base is x, or any expression is fine. So the base is equal to positive or negative square root of the right hand side of the equation. So using this property, let's try some examples. Okay, here is x squared. Okay, we need x squared, so get rid of this first, the coefficient 3. So we can divide each side by 3, then 15 over 3 is 5. Okay, then from this 5, okay, from this x squared, you can get rid of this squared. Then what happens to the right hand side? Plus or minus square root of 5. So there is a positive square root of 5 or negative square root of 5. Okay, there are two solutions. Okay, have a letter B. Okay, the base is x minus 2. In this case, this is a binomial. The base is x minus 2. But you still can remove the exponents. Then the base is equal to plus or minus square root of 10. We are looking for x, so move negative 2 to the other side. Then it will become positive on the right side. Positive 2 plus or minus square root of 10. Okay, this means there are two values, x equals 2 plus square root of 10, or x equals what? 2 minus square root of 10. One is plus, one is minus. So there are two solutions. Okay, letter C is the same. Okay, first, leave the square term alone. So that we gotta move negative 8 to the right. Then 3 minus 6, 3x minus 6 squared is equal to 8. Okay, let me write this one again. 3x minus 6 squared is equal to 8. And then get rid of this exponent. Then we have the base left alone on the left side of the equation. Is equal to what? Plus or minus 8. Plus or minus 8. Square root of 8. Then 3x is equal to, okay, you can move minus 2 to the other side, then 3x is equal to 6 plus or minus, okay, square root of 8 is 4 times 2. 4 times 2. Okay, let me write more. 4 times 2. Then 4 is what? 2, right? Square root of 4 is 2. So 2 square root of 2. And then we want to find x, so let's divide each side by 3. Each side of the equation by 3. And then simplify the equation so that x is equal to what? 6 over 3 is 2. So 2 plus or minus 2 square root of 2 over 3. So this is the solution. This means, okay, this means x is 2 plus square root of 2 over 3, or x equals 2 minus 2 square root of 2 over 3. Okay, this means there are two solutions. One is plus, one is minus. Okay, let's try this exercise. Okay, 16y squared minus 121 is equal to 0. We can use difference of squares because 16 is 4 squared, 121 is 11 squared. But in this case, let's use square root property instead of using difference of squares. Okay, for square root property, write square term on one side and move others to the other side. So negative 121 becomes 121, and then divide 16 each side. Then y squared equals 121 over 16. And then the left hand side is the y squared. So we can get rid of this square. Then the base y is equal to positive or negative, plus or minus square root of 121 over 16. We know that 121 is 11 squared. That is 11 squared, right? So you can write it like this: 11 squared, or 16 is 4 squared. So y is equal to plus or minus 11 over 4. 11 over 4, because the square root of 11 squared is 11. Square root of 4 squared is 4. So one is positive 11 over 4 and negative 11 over 4. Okay, the next one is, here is the square, so the base is m minus 12. So m minus 12 stays one side, and the right side becomes plus or minus square root of 400. Then m equals, can move minus 12 to the other side, becomes plus or minus. Okay, 400 is 20 squared, so m is equal to 12 plus minus 20. So 12 plus 20 and 12 minus 20. So this means m equals 12 plus 20, or what? Or, okay, let me write in 2 lines. Or m equals 12 minus 20. So if it is 12 plus 20, then m will be 32. 12 minus 20, then m is negative 8. So there are two solutions, 32 and negative 8. Okay, next one. Okay, we have something squared, minus 48. So move minus 48 to the other side. 3x minus 5 squared equals 48. And then the base will be, here is a square, this square, so the base 3x minus 5 is equal to what? Plus or minus 48. Then 3x is equal to, move minus 5 to the other side, plus 5. Plus or minus, let's simplify 48. Okay, 48 is 4 times 12, and 4 times 12 is 4 times 12, and 12 is 4 times 3. So isn't it 4 times 12, and 12 is 4 times 3? Because we want to make 48 in a product of something squares. So 3x is equal to 5 plus or minus. Okay, 4 times 4 becomes 4. Square root of 4 times 4 is 4. 4 square root of 3. Then finally, divide each side by 3. So 5 over 3 plus or minus 4 square root of 3 over 3. So this is the solution. Okay, what would happen if the square root is, okay, here is some examples. Okay, let's say x squared equals negative 4. Negative 4. Okay, let's say negative 3. Then we know that x something squared is always positive. Then in this case, there is no real solution. This means there's no real solution. Because something power has to be, real number squared, it has to be always positive. But since we learn imaginary number, the complex number, we can change it to negative. So, I mean the I, the imaginary unit I. So by using the definition square root property, x is equal to plus or minus square root of what? Negative 3. Okay, as you can see here, the square root has negative. The radical is negative. If the index is, remember the index is even. Let's say this one. If the index is even, then what? Then x has to be greater than or equal to 0. Okay, so that this will become a real number, right? Real number. But since the square root has negative as a radicand, this is not a real number. This is what? Imaginary number. Complex number. Imaginary number. So finally, we can rewrite the solution as plus or minus square root of what? 3i. Okay, 3i, the imaginary number. So whenever we have something squared is negative, then this is not a real number, imaginary number. So express the result, the solution as an imaginary unit. Like this, square root of 3i. Don't forget this i. So let's try using this property. Okay, this example 3 has solutions, but they are complex solutions. So this is a complex square root because, okay, for this example, x squared is equal to negative 8. Something squared, real number squared is negative, so this is impossible. X cannot be a real number, so x is what? X is a complex solution. So this is a complex square root. Then what is x? X is plus or minus square root of negative 8. So that x equals plus or minus, what is the square root of 8i, right? 8i, and what is square root of 8? That is 4 times 2. Then square root of 4 is what? 2. Let me write one more step. 4 times 2i. So x equals plus or minus 2 times square root of 2i. So one is positive, one is negative. 2 square root of I. The solution is what? Complex solution. Because the square root has negative 8 inside the square root symbol. Okay, the next one, still same. Something squared is negative, so the solution is not a real number. It's gotta be a complex number, imaginary number. So the base x minus 4 is important. Instead of removing the exponent 2, the base is equal to what? Take plus or minus square root of the right hand side, negative 3. Then x equals, move minus 4 to the other side, plus 4, positive 4, plus or minus. The square root is negative, so this negative sign becomes what? I. So move this I to the outside the square root. So this is the solution. 4 plus square root of 3i, and the other one is 4 minus square root of 3i. There are two of them. One is plus, one is minus. Okay, next one is, still we'll do the same thing. So 2 times 3x minus 5 squared is equal to what? Move 32 to the other side. Okay, and then we need something square, so we don't need this 2. So divide each side by 2. Divide each side by 2, so that negative 32 over 2. Then 3x minus 5 squared is equal to negative 16. Okay, then get rid of this exponent 2, then the base is equal to, the base is 3x minus 5. The right hand side is what? Plus or minus square root of negative 16. Okay, negative 16 is what? Negative 4 squared. So 3x is equal to, move minus 5 to the other side, plus 5, and plus or minus square root of what? 16i. And square root of 16 is 4. So 3x is equal to 5 plus or minus 4i. Okay, we are looking for the x value. So that we gotta divide each side of the equation by 3, get rid of this coefficient of x. So x equals what? 5 over 3 plus or minus 4 over 3i. So there are two solutions, one is plus and one is minus. Okay, let's do some exercise. Okay, the first one is p squared plus 9 equals 0. So move minus 9 to the right side, so negative 9. And something squared is negative, so the solution should be a complex number. Then p is equal to plus or minus square root of negative 9. Then p equals plus or minus square root of 9i, because square root of negative 1 is I. Then p is equal to, okay, then p equals, so there are two solutions, p equals positive square root of 9i or negative square root of 9i. So we usually write plus or minus together instead of separating these two solutions. Okay, next one. Something squared is also negative, so the solution is what? Complex solution. Then the base x plus 5 is equal to plus or minus square root of negative 81. Then x equals, move 5 to the right, negative 5, plus or minus square root of what? What is, okay 81i, let's write the 81i. Then x equals 5 plus or minus 9i. Okay, one is plus, one is minus. Okay, the next one. Okay, 25, so move 25 to the right. 2i minus 3 squared is equal to negative 5. Again, something squared is negative, so the solution will not be a real number. It will be a complex number. Then the base 2i minus 3 is equal to plus or minus square root of negative 25. Then 2i equals, move negative 3 to the right, plus 3 plus or minus square root of 25i. Then 2y equals 3 plus or minus 5i. Finally, divide the equation by the coefficient of y, which is 2. So y equals 3 over 2 plus or minus 5 over 2i. Now I'm going to write 5 over 2 first because it looks like, because I just want to make sure that this is the imaginary part, something I. Like a 2i, 4i, 5i, 5 over 2i. So it is better to separate the coefficient, the numbers and the I. But anyway, this is a product, 5 over 2i. Okay, this example is about surface area. Okay, the surface area of sphere that has the radius r, then the formula is 4 pi r squared. Okay, r is the radius, then the diameter is what? 2r, twice the radius. So we want to find the diameter, which is, okay, the diameter is 2 times the radius. So in order to find the diameter, we gotta know the radius. And the surface area is given 144 over pi square inches. So what we have to do is, first we gotta find the radius first. So using the surface area formula, plug in all the values. The surface area is 144 over pi. So replace s with 144 over pi. So that is equal to 4 pi r squared. Okay, from this we gotta find r. So let's leave r squared and then multiply each side by 1 over 4 pi. Okay, multiply each side by 1 over 4 pi. Okay, so 144 over pi is equal to, okay, let me write this one again. So we gotta get rid of this 4 pi, right? So multiply 1 over 4 pi each side, or divide each side by 4 pi, still fine. 4 pi. And then the right hand side is r squared. The left hand side is 144 over 4 pi squared. So if you rewrite this one, let me write r squared first. Then that is equal to 144 over pi 4 pi squared. I didn't reduce, simplify 144 over 4 because we will make a square root. So 144 is square root of 12, and 4 is square root of 4 is 2. So we'll just leave it. Do not simplify. Then r is equal to what? Plus or minus square root of 144 over 4 pi squared. So that r equals what? Plus or minus square root of 144. Square root of 144 over square root of 4 pi squared. So r equals plus or minus, the numerator is 12, the denominator is what? 2 pi. So r equals plus or minus, now reduced, then 6 over pi. So we have two values, y equals positive 6 over pi, or r equals negative 6 over pi. Okay. And then in this case, the radius is a distance. Then usually the distance is always positive. So we will eliminate this negative value because distance cannot be a negative. So the radius is 6 over pi. So that the diameter is what? 2 times r. So that is equal to 2 times 6 over pi. That's the diameter. So finally, diameter equals 12 over pi inch. Okay, so this is the answer. Okay, in this example, we will learn about equations of quadratic form. Okay, if an equation is in quadratic form, that is something like this. The largest exponent, degree term, is in this case 2x. So the largest exponent is twice the exponent, the second largest degree term. Then this is in quadratic form. So something like this. Example 5. Okay, 4. Okay, the largest degree is 4, and then 4 is twice the second largest degree term. So 2 times 2 is 4. So 4 equals 2 times 2. Then this is in quadratic form. So in that case, we can set this x squared equal to something like u. Then what this one becomes? X to the fourth power becomes u squared. So we can easily set u is equal to what? X squared. Then u squared, then x to the fourth power is u squared. So we can rewrite this equation like u squared minus 13u plus 36 is equal to 0. Then, as you can see here, this is quadratic equation. So when we change this one, we can write it as this. A times u squared plus bu plus c is equal to 0. Where u is equal to what? X to the nth power. Okay. So in this case, now we can solve this equation for u. Okay, for you, not me, for you. So let's factor the trinomial. Then u times u is u squared. 36 is what? 4 times 9. And then both negative. So this is negative 4u. This is negative 9u. So that the factors in the left side of the equation is u minus 4 times u minus 9 equals 0. So as you can see here, from here we get the u values. U is equal to what? 4 or u is equal to 9. We got the u value, but u is not the one we are looking for. We are looking for x. So now use the back substitution. Okay, now u is x squared, so why don't we replace this u with x squared? So x squared is 4, or x squared equals 9. From these two equations, we can find x. Okay, x is plus or minus 4, so that x equals plus or minus square root of 4, so x equals 2, or x equals negative 2. Okay, from this equation, x equals plus or minus square root of 9, so that x equals positive 3 or negative 3. So we have 4 solutions, 2, negative 2, and 3, and negative 3. So whenever we have, this is not a quadratic equation, then make it a quadratic equation. So equation becomes a quadratic quadratic if the largest exponent is twice the second largest exponent. Then we will substitute x squared. We will substitute this variable term with x and with u. Then the x to the fourth power will be u squared. Okay, let's try some other examples. Okay, this equation is not, it doesn't look like a quadratic equation because this is not a square, but we can make it a quadratic equation if it satisfies the equations of a quadratic form. Okay, let's change square root with square root of x with the rational exponent. So 1 over 2. So square root can be written as x to the 1 over 2 power. Then as we can see here, this is x to the first power. So the first power is twice this exponent, 1 over 2. See, 1 is equal to 2 times 1 over 2. So why don't we set this one equal to u? Then this will become always u squared. So, okay, let me write it. Set u is equal to x to the, and this is the square root. Okay, this is actually square root of x, right? Square root of x. Okay, then our equation will be u squared minus 5u plus 6 is equal to 0. So from here we can factor the trinomial. U times u, 6 is 2 times 3 and both negative because the sum of negative 2u and negative 3u is negative 5u. Okay, so the left side of the equation is u minus 2 times u minus 3 is equal to 0. Then from the first factor, u equals what? U equals 2 or u equals 3. And u is not the value that we are looking for. We want x value. So replace this u. Okay, we have this equation and u equals 3, this equation. So from here, from the first equation, replace this u with the original variable, square root of x. Okay, u equals square root of x. So square root of x is equal to. Then we can square each side. Okay, square each side. Okay, square each side. Then x equals what? X equals 4. So when we square each side, we have to check. Always we gotta check the solution. So if x equals 4, will that be equal? True? Will the check? Okay, so 4 minus 5 square root of 4 plus 6 is equal to 0. Okay, then 4 minus 5 times 2 plus 6. Then 10 minus 10 is equal to 0. So 0 is equal to 0. Yes, this is okay. So 4 is a solution. Okay, right? Okay. Okay, then let's try the next one. U equals 3. So square root of x is equal to 3. and then square each side. Then x is equal to 9. And then what do we do? Check, right? Check if 9 is okay. So 9 minus 5 square root of 9 plus 6. Is it equal to 0? Okay, we don't know yet. So 9 plus 6 is 15. Minus 5 times 3. Then 15 minus 15 is equal to 0. So yes, this is okay. So the solution is what? The solutions are x equals 4 and x equals 9. So solution is what? X equals 3, x equals 4, and 9. Solution. Okay, let's check if we can write this one as a quadratic form. Okay, then the largest exponent, so 2/3, is it 2 times the second largest exponent? Okay, then this is equal to 2/3. Yes, this is correct. So multiplying 1/3 by 2 is 2/3. So we can set this as what? U. Then this will be what? U squared. So we can set U equals x to the 1/3 power. Okay. Then the equation is what? U squared minus U minus 6 is equal to 0. So this is a quadratic form. So let's factor the trinomial. 6 is 2 times 3, and negative sign goes on negative 3. So goes on 3. So 2U minus 3U is negative U. Alright, so this equation is the product of U plus 2, U minus 3 is equal to 0. Then U equals what? Negative 2, or U equals 3. Alright, so let's do this way. Since U is negative 2 or U is positive 3, let's replace this U with x to the 1/3 power. Okay, so x to the 1/3 power is equal to negative 2. Then what do we do? Okay, we cube each side of the equation, cubed. Then x is equal to negative 8. X equals negative 8. And then let's check. Okay, check. You know, this takes time, huh? So x to the original equation is x. Okay, x is what? Negative 8. Okay, negative 8 raised to the 2/3 power minus negative 8 1/3 power minus 6. Is it equal to 0? Okay, we don't know yet. And negative 8 is what? Negative 2 cubed, right? Negative 2 cubed raised to the 2/3 power. Even this one, negative 8 is negative 2 cubed. 1/3 power minus 6 is equal to 0. Not yet. We don't know yet. We don't know yet, right? Okay, then we can multiply power to another power, so we can multiply the exponent. Then negative 2. Okay, 3 cancel out, becomes 2 minus negative 2, 3 cancel out, 1 minus 6. Negative 2 squared is what? 4. Minus minus is plus. So plus 2 minus 6. Then 6 minus 6 is equal to 0. So yes, this one is okay. So negative 8 is a solution. Okay, then from the second equation, U equals 1/3. So U is x to the 1/3 power is equal to 1/3. And then raise each side to the 3rd power. Then x equals 1/27. Okay, x is 1/27. Is it 1/27? Did I? Sorry, I'm sorry. Okay, x equals 3. X equals 3, not 1/3. Why did I write 1/3? Something was wrong. So U is equal to what? 3. So now it makes sense. 1/3 is equal to 3. And then we take cube each side. Then x is equal to 27. So once we got this one, what do? We gotta check. Okay, check. So when we check this one, it satisfies the equation. It satisfies the equation. Let me skip. You try. Okay, you try. Then this will satisfy the equation. So the answers, the solutions are -8 and 2. Okay, these two are the solutions. Okay, please check this one. Please check this. Okay, in this exercise, okay, let's check this. The base, okay, in this case, the base is x squared minus 1. And the power is, this is 2, and this is 1. So 2 is 1 times 2. So that, why don't we set this is equal to u? Then this will be what? U squared. So let's set u is equal to what? X squared minus 1. X squared minus 1 to the first power. Then the equation will be u squared minus u minus 6 is equal to 0. So u times u, 2 times 3, and -3. So this is equal to -3u and then -u. So this, the left side is x plus 2, x minus 3 is equal to 0. So that u equals -2 or u equals 3. Right. So from here, since u equals -2 or u equals 3, now let's replace this u with what? X squared minus 1. So x squared minus 1 is equal to -2. Then x squared equals plus 1 each side, then minus 1. Then x equals plus or minus square root of -1, so that is equal to plus, this is plus positive I, negative I. So we got these two values. Okay, from u equals 3, then x squared minus 1 is equal to 3. Replace this u with x squared minus 1, the original expression. Then x squared is equal to plus 1 each side, then 4. Then x equals plus or minus square root of 4. So x equals positive 2, negative 2. So these are the solutions. Positive 2, negative 2, positive I, and negative I. Okay, in this exercise, okay, let's write this one in quadratic form if it satisfies the formula, the rules. Okay, 1/5. Okay, multiply this 1/5 by 2. Then that is 2/5. And this 2/5 is equal to this exponent. So, yes, this satisfies the quadratic form. So we can set this u, then this will be u squared. So we can just write it as set u is equal to what? X to the 1/5 power. Okay, then the new equation is 2u squared plus 3u plus 1 is equal to 0. Then u times 2u, 1 plus 1, then this is 2u, and then u sum is 3u. So the trinomial is the product of u plus 1 times 2u plus 1 is equal to 0. Then from the first factor and the second factor, u is -1 or u equals -1/2. Okay, so u equals -1 or u equals -1/2. So from here, let's replace this u with x to the 1/5. Then what do we do next? To find x, we will raise each side of the equation to the 5th power. To the 5th power. Then x is equal to -1. So we have one value, x equals -1. And then from the right side, okay, x to the 1/5 is equal to -1/2. Then what do? We raise each side of the equation to the fifth power. Fifth power, then x is equal to negative 1 over, okay, 2 to the fifth power is 32. So we have two solutions, negative 1 and negative 1 over 32.